Hey guys, welcome back, and I hope you guys are really working hard to achieve your dream, and I hope that you will really achieve your dream soon. So let's get started with our work. Okay, so today I'm gonna explain you this problem, that is minimum genetic mutation problem. This is a new problem, I guess. Not a new problem. No, not a new problem, but it's okay, it's fine. I don't care about a new problem or old problem. It's just a problem for me and I'm gonna solve it, that's it. Okay, so what I have to do in this one is that 8 character long string is given to me, which is only having character A, C, G or T. Okay, and then so we need to investigate from a gene string, that is start gene, to end gene. Okay, there are 2 strings given to us. Okay, and they both are different. Okay, so we need to figure it out how many changes we will do to start the gene so that we can get end gene. Okay, and at one step we can only do one change to our start gene, like in this example. You can see that only the last of this T is A here in the second one. Okay, only one character we have changed, only one character. So this is only one mutation. This we will call as one mutation. There is also a gene bank. If you change from one gene to another, when you change it, this is only valid when this is in the bank, which is also be provided from that in the question only. Okay, so we have to find that from start gene to end gene, how many changes we have to make in the start gene so that we can get the end gene. And also we have to check that the changes we are making to the start gene are valid or not, so that by checking that they are in the bank or not. Otherwise the changes we are making are not valid and we cannot make that, we cannot do that mutation. Okay, so minimum number of mutations needed to mutate from start gene to end gene, otherwise we will return -1. Okay, so like this, see, AACCGGTT and this AACCGGTA. Okay, only one change, only T will change from A and then we will get our result, that is 1. See, only one change we did and we get our end gene, so that is our output. Like this one, you can see that bank they have provided, this is the bank, and from AACCGGTT to we have got AAC, this C have changed to A, and the last A to T, T to A. Okay, so that has changed, 2 changes are there, and when we will change this C to A, we have to check that that is valid or not. Yes, this is valid, this is present in the bank. Okay, and when we will change from, when this will change to A, then we left with this last T. Then when this will change to A, then we'll check if that is valid or not. That is valid. Okay, so we can get this one also. Okay, okay, now let's start with the problem discussion. Okay, in the min mutation, we will take a queue to visit all the strings and unordered set seen. Okay, to remove the redundancy duplicated mutating gene. If we change like this C to, there are many strings which will come up like this. When we will change this A2, when this will come like same only. Okay, there are many instances when there is a possibility of duplicacy when we will start mutating the start gene. So for that case, we will keep an unordered set which does not store duplicates, so that will help us to remove the duplicated. Okay, then in the queue which we have taken, I will push the start gene, and then in seeing I will insert also the start gene. Okay, then in steps, the steps taken to reach from start gene to end gene. Okay. And while the queue is empty, while the queue is not empty, then only we will run this program. Okay, so that if something is there in the queue, that means we have to check. Okay, from size n, we will store the size of the queue, that is right now 1. Okay, from 0 to 1, J++. Okay, it's from go, so it will run only 1 for 0. Okay, and I will pop the item which is at the front, that is the 1. Let me say this one. Okay, so this one was stored, so I in string n I got this one. Okay, so q.pop, I removed it also from the queue. Okay, Okay, then in this step will work when this step will work when n equals to endgen, when I will get the string that is the endgen. Okay, so this will work and we will return the steps, that is the output we require. Okay, so after that there will be a for loop which will run over the characters like a, c, g, t. Okay, that will run over the characters, and then again a for loop that will run over the size of the string we have taken, that is the start gen we have taken. In first we can see that we have taken start gene only in n, q dot front, that was start gene only, so start gene is there. So till the size, like we will now run over each character. Okay, we will now run over each character of the string. Okay, so after that we will store that in neighbor n. Yeah, we will now make a duplicate of that n, so that we can mutate and check whether it is really same from the one we were here finding or not. Okay, so I duplicated it in neighbor, the n string, and neighbor I, that I want at a place 0 I will place c, that is a will come. At a place c a will come. Okay, so a is there already, so it is a duplicate one. So if scene dot count neighbor, if scene not equals to scene dot count neighbor, that means that if there is neighbor is not present in scene and the count of neighbor is not there. If neighbor is not present in scene, then only we will work. And here we can see that I placed a at the place of a only, so this is present because I already inserted. Here you can see I already inserted in scene start gene, so this will not work. And this condition, if this condition is true, is false, this we don't need to check because there is and. If one is false, that is no matter, we won't run these conditions. Okay, so we will again start the for loop, and then we will go for like this only. We will go for a, c, g, t, a, and we will change each character to a and check whether that character is in the bank. By this find, we will check whether that character is in the bank or not, and if that character is not in the bank and that character is not we have seen, then only we will push that character into our queue. Okay, and we will also insert that character into our neighbor, because that is one step of our reaching the end gene. Okay, then only after one looping of this and one changing of character from all the places, one time it would be like on all the characters you place a, then c, then g, then t. Okay, when this will be done, that is my one step is completed, and I will plus the steps, and I will again come back here to check again with the second string I will get from here, and like that the process will go on and I will get this output. And if I don't get anything like this, I don't get at the end like n equals to end gene, I don't get, then I will return simply -1, which you can see here they have written. If you don't get, then you can return -1. So that is the case. I know this is a very simple problem. Unless you understand it. Yeah, because I thought when I wasn't able to understand it, I thought this is a really hard problem, but that's not the case. It is an easy problem, so you can give it for it. It is a really very easy problem. So I hope I made you understand that. So let's get into the gist. I will just explain you in a very quick, like in just 10 seconds. I have taken a queue, okay, and I've taken an ordered set scene to remove the redundancy mutated genes which are already present. What I will do with those, so I am taking an unordered set so that I remove the duplicate ones. Okay, in q.push I have pushed and single instead I have inserted, then I have checked if they are engine or not. No, they are not engine. Then I will go and change each character and see that they are getting to end gene or not, and if they are not getting to end gene, then whether they are belonging to the bank or not. If they are belonging to the bank, then that is one step of our solution, and then after only we will get our solution. So we will consider that step if that is in our bank. Okay, from that only we will be doing this, and this is a really easy problem. I hope you guys understand it. Thank you. Bye. Keep learning, keep coding, bro.